Welcome to the course module of Communication Engineering. And today, in this lecture, we are going to cover these topics. So these topics are very much important while discussing the random variables and a random process in communication systems. So the topics that we are going to discuss today is basic definition of probability, sample space, events, joint probability, mutually exclusive event, conditional probability, Bayes rule, and independent events. So let's start the this discussion. Okay. So first of all, we have to discuss about the basic concept of the probability. To start with, I will be considering few of the random experiments. So let's consider this random experiments. So if we consider the flipping a coin experiment, throwing a die experiment, or drawing a card from a deck of cards, then one thing which is very much clear is that we cannot be certain the outcomes of the random experiment. So we cannot tell whether if we flipping a coin, the outcome will be a head or a tail. Similarly, in the case of throwing a die, we cannot tell that which number will appear. Like, because we know that in the case of die, there will be total 6 possible outcomes, and therefore we cannot ascertain what will be the output. Okay. Similarly, in case of drawing a card from a deck, we know that there will be total 52 cards. We cannot tell which particular card will come. So therefore, normally if we conduct any random experiments, we know that the outcomes cannot be predicted with 100% certainty. But what we can do is we can define the probability of a certain outcomes. So what is the basic definition of the probability? So the probability definition is this: the total number of favorable outcomes divided by the total number of possible outcomes. So let's try to understand this particular equation. So if we consider this to experiment flipping a coin or throwing a die, we know that in the case of flipping a coin, there will be two outcomes, head and tail. Okay. So if we consider what is the probability of coming outcome as head, then we know that there are only two, means there will be total two outcomes, head and tail, and only one time this head can come. Okay. So therefore, if we follow this particular formula, this probability will be come out as 1 by 2. And this is the probability of coming tail. Okay, coming tail and head will be same. Okay, in this particular case. Similarly, so if we consider the throwing a die experiment, then there are total 6 possible outcomes, 1, 2, 3, 4, 5, 6. So normally the total number of outcomes, okay, possible outcomes of a particular random experiment is known as the sample space. So therefore, I have written here, because here there are total 2 possible outcomes, head and tail. This will form the sample space. And for this particular experiment, these 6 numbers will form the sample space. So if we ask you what is the probability that after throwing a die, the number 3 will appear, then we can find it out by following this formula, that the probability of coming 3 in this particular experiment is 1 by 6. So how it is 1 by 6? Because there are total 6 possible outcomes, and only one time 3 outcome as 3 is possible. So therefore it is 1 by 6. So now here you can see this definition of the sample space. So sample space is a set of all possible outcomes of a random experiment, right? Similarly, we can have a discrete sample space. So what does it mean by a discrete sample space? So in the case of discrete sample space, the sample space will consist of finite number of outcomes, finite number of elements, or it can be a countably infinite number of elements. Otherwise, it will be a non-discrete sample space. So here you can easily see that these outcomes are your discrete. This sample space is nothing but your discrete sample space. Now you try to understand this particular question. Okay. So if we conduct a random experiment of throwing a die, okay, if we conduct this particular experiment, and if we wish to find out what is the probability of getting an even number, or if we want to find out what is the probability of getting a number which is greater than 3, if we wish to find out these two probabilities, right, then how to find out these probabilities, right? So we know that there are total 6 possible outcomes if we throw a die. Then here you can see that we can have 3 numbers which are even. Okay, 2, 4, and 6. So out of 1 to 6, these numbers are actually even, 2, 4, 6. Similarly, probability of getting a number which is greater than 3. So that outcomes will be 4, 5, 6. Right? So if we wish to find out what is the probability of uh, this particular question number A. Okay, what is the probability of getting an even number? So this probability we can define, and that probability we can write here. If this outcome of getting an even number, if it is represented by outcome 1, then that can be written as probability 2, comma 4, comma 6. Okay. So this probabilities you can write here is as probability of 2, getting the probability 2, getting the probability of 2 plus getting the probability 4 plus getting the probability of 6. So if we add this all probabilities, okay, then we will be able to calculate the total probability of getting the even number. So here it is 1 by 6, 1 by 6, 1 by 6. If you add them, we are going to get this probability equals to 1 by 2. Similarly, here, if we wish to know what is the probability of getting a number which is greater than 3, then that will be 4, 5, 6. So here you can write this probability. So this probabilities will be getting the probability of 4, probability of 5 plus probability of 6. So it is the summation of this all three probabilities. So that probability is 1 by 2. So here we can see that we can define these probabilities as an event, okay? Because this particular probability that we have shown here, like what is the probability of getting an even number, that may be defining a particular subset of the complete sample space, okay? So here we can define what is the event. So events are the subsets of the sample space for which a probability can be defined. So basically here, if we are saying that what is the probability of getting an even number, then that can be said as a event. Okay, this can be regarded as one of the event. Okay, because there are total 6 possible outcomes. Out of the 6 possible outcomes, we are defining a different subset. Okay, and that subset is including all the even numbers. Similarly, we can have another subset in which we can say that what is the probability that the number which we are going to get is greater than 3. So this is another subset. So this subsets of the probabilities are known as the events, right? So now we can define the joint probability. Okay, so what does it mean by the joint probability? So to understand the joint probability, try to understand this question. Okay, so what is the probability that the outcome will be an even number and it will be greater than 3? Okay, so here I want to know what will be the probability in this particular experiment, what will be the probability that the outcome will be an even number as well as it will be greater than 3. Okay, so here you can see that it should be greater than 3, first of all. Okay, it should be greater than 3 and it should be an even number. So we can see that it is 4 and 6, which is the only possible outcomes, right? So here we can define this joint probability. So how to define this joint probability? Because here this joint probability means this represents the outcomes which are common to both outcome 1 and outcome 2. Okay, here this is the outcome 1 and here is the outcome 2. So it is common to both this outcome 1 and outcome 2. So normally this can be represented as a probability of getting outcome 1 comma outcome 2. And normally in this set theory, if you see, these probabilities are represented by this intersection sign. Okay, so here this probability P can be represented by outcome 1 intersection with outcome 2. So it is the common outcomes. Okay, it is the common outcomes which we have to define in between the outcome 1 and outcome 2. So this can be written either this way, probability outcome 1 intersection outcome 2, or it can be represented as probability outcome 1 comma outcome 2, or it can be also written as probability that both outcome 1 as well as the outcome 2 will occur simultaneously, right? So here this probability which are possible outcomes, that is even number as well as it is greater than 3, is the probability of getting 4 comma 6. So it will be probability of getting 4 plus probability of getting 6, which is equals to 1 by 3, right? So this is your joint probability. Okay, this is your joint probability, right? So this way we can define the joint probability. Now, here you try to see another problem. So think about what is the probability of getting an even number. Okay, that we have already discussed. Then what is the probability of getting an odd number? And then we have to answer this third question: what is the probability of getting either even number or an odd number, right? So here you can see this. If we consider this problem, okay, I have already shown you what is the probability of getting the even number. So that probability is 1 by 2. Similarly, we can also define what is the probability of getting the odd number, which is again coming out as 1 by 2. Now, suppose if we wish to calculate what is the joint probability in this case, right? So what is the joint probability here? That we want to know that what is the probability that if we conduct this experiment, the number will be an even number as well as the odd number. Okay, so is it possible to have such outcomes? This is my question. Is it possible to have this outcomes that if we conduct an experiment and if this output should be even number as well as the odd number? It is not possible, right? It is not possible. And therefore, the joint probability of these two events, right? If these two events are zero, we cannot have simultaneously a number, outcome, which is even number as well as the odd number. And therefore, normally what happens, this both events cannot happen together, right? This you remember. So whenever such condition occurs where the joint probability between the two events or more than two events are zero, it means that both the events cannot happen together. And normally such events are known as mutually exclusive events, which is also known as disjoint events. Okay, so this is the very important class of your events that you have to remember. Okay, so to any two events or more than two events to be mutually exclusive, this joint probability must be equals to zero, right? Now you try to see what is the probability of getting either even number or a odd number. So here we have already seen, because there are total 6 outcomes. So if we throw a die, obviously the output or outcome of this experiment, either it will be a even number or odd number, even or odd. Okay, because these numbers are only even or odd numbers that we are going to get. So obviously in this case, we can define this probability, that what is the probability that the either the number will be even or odd. This will be denoted by this union operator in the set theory. Okay, so this probability E, either E or means probability of getting either even number or odd number. It can be represented by probability of E union O. Okay, it means that it contains all the outcomes of event 1 as well as event 2. It is containing all these possible outcomes. Okay, so here we can see that because these numbers are 2, it is covering 2, 4, 6, and it is covering 1, 3, 5. So obviously the probability of getting either even number or odd number is equals to 1. That here you can prove it. Okay, it is very simple to prove, right? So P of getting either E or O, okay, this will be equals to 1 by 2 plus 1 by 2, and this probability is going to be 1. So similarly, this particular case, if you see, if we have L possible mutually exclusive events, okay? If it is L possible mutually exclusive event, so what is the mutually exclusive event? Just I explained you. If the joint probability of this mutually exclusive event will be going to be 0. Okay, in that case, if there are such L possible mutually events, okay, mutually exclusive event, in that case, if we consider this particular outcomes, okay, this outcomes, P outcome, probability of getting outcome 1 union outcome 2 union up to outcome L, all this summation is going to be equals to 1. Okay, because it can be followed from this particular explanation only. Here you can see that the probability of getting the even number plus probability of getting the odd number, these are the two different events which are the mutually exclusive in nature, and therefore the summation of the two is equals to 1. So obviously we are having such L possible mutually exclusive events, then again the total probability, the sum of the total probability is going to be equals to 1. Now here I will explain you a conditional probability. So try to understand that what is the probability, this conditional probability with this example. Okay, so let's try to understand this particular container, which is containing a certain number of balls, and these balls are having different colors. So let me ask you one question. If we are having this particular case, then what is the probability of drawing a certain balls? Okay, so here we can see, because the balls are in equal numbers, green balls are 3, red balls are 3, and again the blue balls are 3. If we wish to calculate what is the probability of drawing the red ball, green ball, or blue ball, then we can show this as the probability of drawing the red colored ball is, obviously there are total 9 outcomes possible. Okay, and drawing 3 red balls. Okay, drawing a red ball, so there are total 3 red balls, so there are total 3 favorable outcomes. Okay, so we can write this as 3 by 9. Okay, so number of favorable outcomes are 3, and total number of total number of possible outcomes are 9. So it will be 3 by 9. So here we can write the probability of drawing red ball is 1 by 3. Similarly, for all the other two cases, we can write the probability of drawing green ball or blue colored ball. It is again 1 by 3 and 1 by 3. Now consider this state 2. So let us suppose that we have already drawn a red ball. Okay, in the first case. Okay, in this particular state 1, I have already drawn a red ball, and this red ball has not been replaced into the container. Okay, so now this will become this system 2. This is the state 2 of your system. So now the system has changed, that you have to remember, because initially we had total 9 balls. Okay, and now after conducting the experiment at the first draw, we have drawn this particular red ball. Now the condition has changed. Okay, now this system is having total number of balls is equals to 8, in which we are having 2 red balls. Now if I ask you, now what is the probability of drawing the red ball? Okay, so here you can see this probability will change now. Okay, so the probability of drawing the red colored ball is now, if you see, there are total 2 such red balls. So number of favorable outcomes is 2, and the total number of outcomes are 8. So it is 2 by 8. So here you can see this probability will become 1 by 4. Okay, so here you can see the probability of drawing red ball, again the probability of drawing the green ball, or probability of drawing the blue ball, is actually depending on the last case, the last ball drawn. Okay, in the first case, right? So here you can see these all probabilities are now changed. It is 1 by 4, it is 3 by 8, it is 3 by 8. Okay, so this way we are having the probabilities in the state 2 when the first ball drawn was red. Okay, so now again, if we consider that, if in the first case, if the ball drawn was red, and if we again replace this ball inside this particular container. Okay, so if we again replace this ball, okay, if we replace this ball, then again we'll get the same system. Okay, the system is, this state 3 is nothing but the same system state which is available in the state 1, right? So again we are having the all these 3 balls, all these 3 balls, right? Red 3 ball, there are 3 red balls and 3 green balls and 3 blue balls. So again, if you wish to calculate, okay, what is the probability of drawing red, green, or blue, obviously it will be remain same. This probability will remain same as it was in the state 1, right? So these probabilities here we can rewrite. It will be again 1 by 3, 1 by 3, and 1 by 3. So one thing that we have to understand here is that in the case in the state 2, okay, if you see, normally here you can see this state 1 and state 3 are the same experiments. Okay, because the system are same. Okay, these two systems are same, right? Are the same experiment, but the state 2 is a new experiment. Why it is a new experiment? Because system has changed, right? The system has changed because one of the ball was already drawn and it was not replaced again. Okay, so this container is containing number of balls which is different from the state 1, and therefore drawing the ball from this state 2 is a different state. Okay, so here we can see that in the state 2, the probability of drawing any ball will depend on the outcome of drawing the ball in the first state. Okay, so what was the ball which was drawn in the first state? If it is not replaced, then obviously the probability of drawing any other ball is going to be impacted. These probabilities are actually impacted due to the drawn ball. Okay, so therefore here you can see that this conditional probability we can define like this. It is probability of O2 for given O1. Okay, so this outcome 2, we have to calculate what is the probability of getting outcome O2 for given outcome O1. right? So this particular probability outcome O1 is already occurred in the previous case, right? So here it is the probability of occurrence of the outcome O2 when the outcome O1 has already occurred. So this is nothing but your conditional probability, right? So we can have a certain system in which if we conduct the experiment in succession normally, okay, if we conduct any experiment in succession, and if the experiment conducted in the first step, okay, if it is not replaced, then obviously in the next step, the probability of conducting the experiment, okay, the probability of getting any particular outcome will be impacted by the outcome in the previous state. So this type of probabilities, okay, is known as your conditional probability, right? This is your conditional probability. Now again, see one more system. Okay, here you try to understand this particular case, right? So that was our conditional probability, and now you here try to understand this particular problem. Okay, so what is this problem? So let's try to answer this question for this particular system. So let's try to answer this problem. What is the probability of drawing a red ball for this particular system? Okay, so obviously, calculating this probability is fairly simple. So we can count how many balls are there. So it is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so total 11 number of balls. So if we wish to calculate what is the probability of drawing the red ball, so obviously that probability will be how many red balls? 4, and total outcomes are 11. So it is 4 by 11. Okay, so this probability is very simple. Now I can ask you what is the probability of drawing the green ball in succession when the first ball drawn was red. Okay, so it is already known that in the first case we have already drawn the red ball. Then what is the probability of drawing green ball in succession, right? So these probabilities you can calculate, and we know that in the second case it is the conditional probability that we have to find out, right? So here we can see this example. So drawing the red ball is 4 by 11. And in the succession, if we wish to know what is the probability of getting the green ball when this red ball was not replaced, then you can see this answer. So this is your uh, probability of getting the red ball when in the first case, it is the probability of getting the green ball when in the first case the red ball was drawn. Okay, so this is the conditional probability. Okay, it is the probability of getting green ball for a given red ball. Okay, which is already occurred in the first case, right? So here we can see that what is the probability of getting the green ball? So that is depending on this particular system. So how many balls are left now? It is 10 total outcomes. Okay. 10 total outcomes are possible. And how many green balls are there? 1, 2, 3, 4, 5. So it is 5 by 10. So this probability of getting the green ball in succession when in the first step the red ball was already drawn is equals to 1 by 2. So now try to consider another experiment, which is just the reverse of your first experiment. Okay. So if we do this reverse operation, okay, you try to understand again. If we let us say, what is the probability of drawing a green ball? Okay. Here the system is remain same. And let me ask you, just you perform this reverse experiment. Okay. What is the probability of drawing a green ball? So obviously here, if you want to calculate what is the probability of drawing the green ball, this will be obviously 5 by 11. Why it is 5 by 11? Because there are total 11 balls and there are 5 favorable outcomes. So 5 by 11, this will be the probability of drawing the green ball. Now we want to calculate what is the probability of drawing a red ball in succession when the first drawn ball was green. Okay, so I'm just conducting this experiment in a reverse order. Okay, as compared to your first case, right? So if we wish to calculate, now we have to calculate this conditional probability that it was a green ball which was drawn. Then what is the probability that in the next step we are going to get the red ball? Okay, in succession. So if you wish to calculate what is the getting the red ball, okay, in succession is probability of R given G, it is equals to how many balls are there? It is 10. And how many red balls are there? It is 4. So it is 4 by 10. So this probability is going to be 2 by 5, right? So now you try to understand one particular rule, which is known as the Bayes rule. Okay. So basically here, what we can do is, here we are trying to, in the first case, we are trying to calculate probability of getting green ball for a given red ball. Okay. And this particular probability, we can also calculate in this fashion. Okay. If we have this probabilities, this individual probability, what is the probability of drawing the green ball? Okay. In this particular first case, if we perform the this experiment in reverse order, what is the probability of getting the green ball? And here, what is the probability of getting the red ball? Okay, then multiplied with this is the reverse conditional probability. You see this. If you want to calculate probability of what is the probability of getting the green ball when the red ball was drawn, that can be calculated by calculating this particular equation. Okay, it is PG by PR multiplied with P multiplied, it is the probability of getting the red ball for a given green ball, right? So if we have this reverse conditional probability, okay, then you can see this, what is this calculation and what is the number that we are coming out. So this PGR, okay, this probability of getting the green ball, this conditional probability, you can calculate what is the PG. So this PG was 5 by 11. And what is PR? This was 4 by 11. And here P, what is this R given G? It is 2 by 5. Okay. So if you do this simple manipulation, you will find this probability is coming out as 1 by 2, which is same as this particular equation, whatever we have calculated directly. Similarly, here again, you can see if in this case, if you wish to calculate this P R given G, okay, then this probability will be PR divided by PG. Here you can see this is PG oblique R. So here it was PG divided by PR, and then it is a reverse conditional probability. And here you can see it is P R given G. So it will be PR divided by PG multiplied with P G given R. Okay. So this can be calculated. It is, you can see, you can substitute this value PR and PG and PG given R is 1 by 2. If you substitute this value again, it is going to be 2 by 5. Right. So it means that there is a possibility if we have the reverse conditional probabilities, okay, then we can calculate this particular probability in the terms of reverse conditional probability. This is known as the Bayes rule. Okay, this is a very fundamental rule. You have to remember this point. It is a very important rule. Okay, so normally Bayes rule says that one conditional probability will be represented in terms of reverse conditional probability. Okay, and this way we can calculate the given conditional probability, right? So this way we can calculate this particular conditional probabilities. Now try to answer another question. Okay, so let's try to understand this problem. Okay, so you have understood these two first problems. Now try to understand this particular problem. If the two balls are drawn in succession, okay, if the two balls are drawn in succession, just consider these systems only, right? If the two balls are drawn in succession, then what is the probability that the first ball is red and the second ball is green, provided the red ball drawn in the first case was not replaced? Okay, so here we have to talk about that particular probability in which the first ball must be a red ball followed by a green ball. Okay, we have to talk about this probability jointly. Try to understand this problem. Okay, so here we were actually interested only in that what is the probability of drawing the green ball. You try to understand, you try to differentiate between these two problems. In this first problem, here you can see in the first statement, what I wrote is, what is the probability of drawing a red ball? That was 4 by 11. Fine. Then the second problem is, what is the probability of drawing the green ball in succession when the first ball drawn was red? So we are just interested in knowing what is the probability of drawing the green ball. Okay. So that was your P, probability of getting green ball for a given red ball. So that is the conditional probability we got as 1 by 2. But now here we have to answer this problem. What is the probability that the first ball is red followed by green? So there is a sequence R and G. What is the probability that the ball will be drawn twice and the first ball will be red and the second ball will be green? What is the probability? So this is the joint probability of this particular two balls, right? So here you can see we can define this joint probability, right? And that joint probability will be defined by this particular equation, probability of R intersection G. Okay, and that will be the first case. We know that the first case, drawing the red ball, is the probability of drawing the red ball. And again, in the second case, it will be multiplied with this particular probability. What is the probability of it is the conditional probability of drawing the green ball when in the first case the red ball was already drawn. So this is the actual probability. Okay, and that you can calculate here. The first case, the probability is 4 by 11 multiplied with 1 by 2. So what is the probability that this sequence of a red ball followed by green ball will occur? It will be obviously 4 by 11 divided by 1 by 2 plus multiplied with 1 by 2. So it will be 2 by 11. So that probability is 2 by 11. So this way we can define the joint probability. And obviously here you can write this joint probability PR intersection G. It can also be written as probability of drawing green ball multiplied with the probability of drawing the red ball to the given conditional probability G. Again, you will be, if you solve this, again, you are going to get this 5 by 11 multiplied with 2 by 5. So again, you are going to get 2 by 11. So this is your joint probability. So now one important class of events we can define here is that, and that uh, probability is independent events, right? So what does it mean by independent event? Okay. So here you can see that in this particular case, when the ball was drawn in succession, what was the condition? The first ball was not replaced. Okay, the first ball was not replaced. So suppose that if this was not the case, we have already drawn the first ball and the first ball was a red ball. And after that, this red ball was again replaced into the container. Okay, then if we ask you what is the probability that the next ball will be green? Okay, so in that case, we know that there will be no conditional probability of drawing the green ball because the red ball drawn in the first case was already replaced. Okay, it is already available in the container and the system doesn't changes. And therefore, if we want to calculate what is the joint probability of getting red in succession with the green ball, that will be the probability of drawing the red ball independently multiplied with the probability of drawing green ball independently. So such system in which this joint probability is actually defined by the independent probabilities. It is the multiplication of the independent probabilities is normally known as the independent events. So the meaning is that the occurrence of the second outcome does not impacted by the outcome of your outcome in the first case. Okay. So first outcome, whatever it may be, because the ball is again replaced, the system doesn't changes, and therefore you cannot have any impact onto the probability of drawing that particular ball. So normally you can see that this conditional probability PG given R is equals to PG, okay, in the case of independent events. And similarly, PR given G is again equals to PR because it is the independent events, okay. The ball is again replaced into the container and therefore it is going to be uh, it should not be a conditional probability. So I hope you must have understood something. So please follow this lecture if you have any doubts. So we stop here today. Okay, our topic is covered. So if you have any query, if you have any doubt, you can drop your message into the comment box. I will try to answer those problems. Thank you for watching this video.